Hello everyone, welcome to Let's Crack UPSC CSE English. In today's NCERT Marathon series, we will discuss about atmospheric circulation and weather systems. Now friends, in earlier session, we have discussed about the topics of physical geography, where we have covered about solar radiation, heat balance and temperature. Now, start with the atmospheric circulation and weather systems. So here friends, in this unit of climate, we are discussing about atmosphere, insolation, pressure, precipitation and world climates. So till we have covered these units and now we are continuing the climate. So let's continue with the atmospheric circulation and weather systems. So friends, you can share the link with your friends so they'll also join the session. Atmospheric circulation and weather systems. So friends, in last chapter we have discussed about the uneven distribution of temperature over the surface of the earth. Now, the air expands when heated and gets compressed when cooled. So, air which expands when heated and get compressed when cooled. So this results in variation in the atmospheric pressure, and the result is that it causes movement of air from high pressure to low pressure. So setting the air in motion. So we already discussed about the air in horizontal motion. is wind. Now, so atmospheric pressure, which also determines when the air will rise or sink. Now, the wind redistributes the heat and moisture across the planet. Now, basically, maintaining a constant temperature for the planet as a whole, the vertical rising of moist air, which cools it down to form the clouds and bring precipitation. So friends, in this chapter, we will discuss about the causes of pressure differences, the forces that control the atmospheric circulation, and the turbulent pattern of wind. So the formation of air masses, the disturbed weather when air masses interact with each other, and the phenomenon of violent tropical storms. Now, atmospheric pressure. So let's start with the topic atmospheric pressure. Now friends, before going to continue the session, yes, it's my pleasure to welcome you all on Unacademy, India's largest learning platform. It's me, Rushikesh Inamdar, guiding UPSC aspirants from last 8 years. Friends, you can follow me on Unacademy app to get notifications about our free special classes. For that, just go through the Unacademy app. In search window, just find out my name and follow my profile. You can also join our Telegram group to get important updates about civil services preparation. The link is provided in the description box. Now friends, as you know that recently UPSC announced final results of Civil Services Examination 2020. Congratulations to all successful candidates, including Jagriti Avasthi, Unacademy learner, who secured All India rank 2nd. Friends, there are 169 plus Unacademy learners cracked the UPSC CSE 2020, still we are counting the numbers. Now you can continue your preparation with Unacademy, where we will support you throughout the phases of preparation. So friends, here is the limited period offer where you will get additional 10% discount. Now from today, tomorrow and day after tomorrow, for the limited period you will get additional discount of 10%. We will discuss the offer in the later part also. So do not forget to use the referral code RBI Live while subscribing the courses. Friends, every Sunday we are conducting Unacademy Combat. Now just remember that upcoming Sunday, that is 3rd October morning 11 am, we have Geography Combat. You can participate, and before that you can register yourself using invite code RBI Live. The link is provided in the description box. Upcoming Sunday, 3rd October, morning 11 a.m. UPSC CSE Geography Combat, where you will get amazing prizes and scholarships up to 100%. Along with that, dear friends, you will get study material in hard copy, and the study material worth rupees 10,000 you will get absolutely free with 1 year and above subscription. Yes, with these courses. And friends, no cost EMI or loan facility is available. So you can apply for the same through the link given in the description box. For the 10% discount, you can apply the code RBI Live. So friends, we have Iconic and Plus paid subscription on our platform, where in Plus subscription you will get live classes, structured courses, unlimited access for live and recorded classes, along with weekly test. Now, those aspirants pursuing their graduation or after their 12th examination, planning to start their preparation for civil services, they can go with Iconic subscription, where friends you will get all the features of Plus course along with additional features like personal guidance, study planner, study material, experts guidelines and test analysis. So friends, you can start your preparation with Iconic subscription. And friends, you can avail 10% discount using referral code RBI Live, where for the 1 year of Plus subscription you have to pay 44,550 rupees, and for the 1 year of Iconic subscription you have to pay 67,050 rupees only. Now, you will also get 10% discount using referral code RBI Live on optional subscriptions. And do not forget to register yourself for free test series. You can unlock the test using code RBI Live. Now let's continue the topic of our today's session, Fundamentals of Physical Geography, Part 10. Yes, atmospheric pressure. Now, friends, do you realize that our body is subjected to a lot of air pressure? Now, as one moves up, the air gets verified and one feels breathless. How many of you visited high altitude places or visited the Leh Ladakh? Now, dear friends, Normally the weight of column of air which contained a unit area from the mean sea level to the top of the atmosphere is called atmospheric pressure. So the weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere is called atmospheric pressure. Now, the atmospheric pressure is expressed in units of millibar. At sea level, the average atmospheric pressure is 1013.2 millibar. So due to gravity, the air is, yes, due to the gravity, the air at the surface is denser and hence has higher pressure. Now, air pressure, which is measured with the help of a mercury barometer or aneroid barometer. Yes. Now, the pressure which decreases with height at any elevation, it varies from place to place, and its variation is the primary cause of air motion, that is wind which moves from high pressure areas to low pressure areas. So normally wind which moves from higher pressure to low pressure areas Now, the vertical variation of pressure we will discuss. So friends, the atmospheric pressure will once revise, like our body subjected to a lot of air pressure. Now, as one moves up, the air gets verified and one feels breathless. Now, the weight of a column of air which contained in a unit area from the mean sea level to the top of the atmosphere is called as atmospheric pressure, and the atmospheric pressure is expressed in units of millibar. Right. Now, at sea level, the average atmospheric pressure is 1013.2 millibar. Due to gravity, the air at the surface is denser and hence has higher pressure. Now, the air pressure is measured with the help of a mercury barometer or the aneroid barometer. So the pressure decreases with height, and at any elevation it varies from place to place, and its variation is the primary cause of air motion. So that is wind which moves from high pressure areas to low pressure areas. Now, let's continue with the vertical variation of pressure. Now friends, just make short notes properly. We are taking time, or we are completing these NCRTs page by page, because these concepts which build your foundation. So friends, take your time, understand the concept, and then move ahead. So now next, we will discuss about vertical variation of pressure. Now friends, in the lower atmosphere, the pressure decreases rapidly with height, and the decrease amounts to about 1 millibar for each 10 meter increase in elevation. Now, it does not always decrease at the same rate. Now, here is the table given, which gives the average pressure and temperature at selected levels of elevation for a standard atmosphere. Yes. See, at the sea level, the pressure is 1013.25 millibar, and temperature which is around 15.2 degrees Celsius. At the 1 kilometer, the pressure is 898.76 millibar, and temperature is around 8.7 degrees Celsius. Then at the 5 kilometer, pressure is 540.48 millibars, temperature is minus 17.3 degrees Celsius, and at the height of 10 kilometers, the pressure is 265.00 millibars, and temperature is minus 49.7 degrees Celsius. Now see, now the vertical pressure with gradient, yes, vertical pressure gradient force is much larger than that of horizontal pressure gradient. Now, but it is generally balanced by nearly equal but opposite gravitational force. Hence, we do not experience strong upward winds. Now, vertical variation of pressure. Yes, friends, you can make short notes or the table if you want to remember. You can just go through it. Yes, the level pressure in millibars, temperature, yes, like sea level 1 kilometer, 5 kilometer, and 10 kilometers. So now, after that, we will discuss about the horizontal distribution of pressure. Just make short notes on this. Now, let's discuss about the horizontal distribution of pressure. Now, friends, horizontal distribution of pressure. Now, solve a small difference in pressure are highly significant in terms of wind direction and velocity. So, horizontal distribution of pressure is studied by drawing isobars at constant levels. Now, isobars are lines connecting places having equal pressure. Now, in order to eliminate the effect of altitude on pressure, it is measured at any station after being reduced to sea level for purposes of comparison. Now, the sea level pressure distribution, which showing in the next map, we will discuss that. So, the figure in front of you, which shows the patterns of isobars corresponding to pressure systems. Now, low pressure system is enclosed by one or more isobars with the lowest pressure in the center, and high pressure system is also enclosed by one or more isobars with the highest pressure in the center. Now, Here friends, let's see the isobars pressure and wind system in northern hemisphere. If you want, you can make short note or the diagram like the low pressure, high pressure, and then ridge is also there. Now, see the isobars pressure and wind system in northern hemisphere. Now, let's discuss about the world distribution of sea level pressure. Friends, the world distribution of sea level pressure in January and July. Now, near the equator, the sea level pressure is low. And the area is known as equatorial low, which is along 30 degrees north and 30 degrees south are found, and the high pressure areas known as the subtropical highs. Now, further polewards along 60 degrees north and 60 degrees south, the low pressure belts are termed as subpolar lows. So near the poles, the pressure is high and it's known as polar high. Now these pressure belts are not permanent. In nature, and they oscillate with the apparent movement of the sun. So in the northern hemisphere in winter, they move southwards, and in the summer northwards. So see the distribution of pressure in the month of January. Now, just try to note down the few things like ITCZ, then high pressure, low pressure, like high, low, high and low. Now, now, friends, I hope you have write down the rough picture of this. Now let's go with the distribution of pressure in millibars in July month. Yes, now we will discuss in detail also. Then we'll discuss about the forces affecting the velocity and direction of wind. So just make a picture, then we'll continue with the next one. So guys, let's start with the forces affecting the velocity and direction of wind. I hope you make the diagram. I'll give you time once again. So let's discuss about the forces affecting the velocity and direction of wind. Now friends, the air is set in motion due to the differences in atmospheric pressure Now, the air in motion is called as wind, as we have discussed. So, the wind blows from high pressure to low pressure, and the wind at the surface experiences friction. In addition, rotation of the earth also affects the wind movement. Now, the force exerted by the rotation of the earth is known as the Coriolis force. Yes. Coriolis force. Now the horizontal winds near the Earth's surface respond to the combined effect of three forces. One is the pressure gradient force, then frictional force and the Coriolis force. Now in addition, the gravitational force acts downward. Now we will discuss with the pressure gradient force. Now those who have not completed the diagram, I'll give you 2 minutes more, so you can 2 to 3 minutes you can complete the diagram, and then we will discuss about pressure gradient force. Yes, finish the distribution of pressure in July month. Yes. So let's discuss about pressure gradient force. Now, the differences in atmospheric pressure produces force. Differences in atmospheric pressure produces force. Now, here the rate of change of pressure with respect to distance is the pressure gradient. So, the rate of change of pressure with respect to distance is the pressure gradient. Now the pressure gradient is strong where the isobars are close to each other. Now the isobars are close to each other and is weak where the isobars are apart. So this is a pressure gradient force. Now discuss about the frictional force. So friends, after the pressure gradient force, now let's discuss about frictional force. Now friends, the frictional force, it affects the speed of the wind. It is greatest at the surface and its influence generally extends up to an elevation of 1 to 3 kilometers. So over the sea surface, the friction is minimal. Friction is minimal. Now, Coriolis Force. So friends, the rotation of the earth about its axis affects the direction of the wind. So the rotation of the earth about its axis affects the direction of the wind. So this force is called Coriolis force. Now, this force is known as Coriolis. Excuse me, friends. Coriolis force. Now, so the French physicist who described this Coriolis force in 1844. Now friends, it deflects the wind to the right direction in northern hemisphere It deflects the wind to the right direction in northern hemisphere and to the left direction in southern hemisphere. Now the deflection is more when the wind velocity is high. Yes. So now friends, the deflection is more when the wind velocity is high. Now the Coriolis force is directly proportional to the angle of latitude, and it is maximum at the poles and is absent at the equator. See, the Coriolis force, which acts perpendicular to the pressure gradient force, and the pressure gradient Yes, and the pressure gradient force is perpendicular to an isobar. Now the higher the pressure gradient force, the more is the velocity of the wind and the larger is the deflection in the direction of wind. Now as a result of these two forces operating perpendicular to each other in the low pressure areas, the wind blows around it. Now at the equator, the Coriolis force is 0. And the wind blows perpendicular to the isobars. Now the low pressure gets filled instead of getting intensified, and that is the reason why tropical cyclones are not formed near the equator. Yes, that is the reason why tropical cyclones are not formed near the equator. So we were discussing this Coriolis force is 0 at the equator, where the wind blows perpendicular to the isobars and the low pressure gets filled instead of getting intensified, and that is the reason why tropical cyclones are not formed near the equator. Now, let's discuss about pressure and wind. So friends, the velocity and direction of the wind are the net result of the wind generating forces. So the velocity and direction of the wind are the net result of the wind generating forces, the winds in the upper atmosphere, that is 2 to 3 kilometer above the surface, are free from frictional effect of the surface and are controlled mainly by the pressure gradient and the Coriolis force. So when isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobars. So this wind is known as the geographic wind. Now, when the isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. Now this wind is known as the geostrophic wind. So see, at the northern hemisphere and southern hemisphere, geostrophic wind so the resultant wind blows parallel to the isobar and this wind is known as geostrophic wind, not geographic, geostrophic wind. Yes, just correct the line. When isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. This wind is known as the geostrophic wind. Now see the diagram where pH stands for the horizontal pressure gradient, V stands for geostrophic wind and C is the Coriolis force. Now, let's discuss about the pressure and wind in detail. Now friends, after geostrophic wind, now the wind circulation around a low, which is known as cyclonic circulation. So around the high, it is called anticyclonic circulation. The direction of winds around such systems changes according to their location in hemispheres. We'll discuss in the table. Now, see, the wind circulation at the Earth's surface around low and high on many occasions is closely related to the wind circulation at higher level, and generally over low pressure area the air will converge and rise. Over high pressure area, the high pressure area, the air will subside from above and diverge at the surface. Now, apart from convergence, some EDs, convection currents, orographic uplift and uplift along fronts cause the rising of air, which is essential for the formation of clouds and precipitation. Now, we will discuss all those things in detail. Now, see the simple diagram which showing the convergence and divergence of winds. Now friends, let's move to the general circulation of the atmosphere. After this we will discuss about general circulation of the atmosphere. Now, see the pattern of planetary winds, which largely depends on latitudinal variation of atmospheric heating, then emergence of pressure belts, the migration of belts, following apparent path of the sun. Then the distribution of continents and oceans and the important one, rotation of Earth. So the pattern of the movement of the planetary winds is called the general circulation of the atmosphere, and the general circulation of the atmosphere, yes, the pattern of the movement of the planetary winds is called the general circulation of the atmosphere, and the general circulation of the atmosphere also sets in motion the ocean water circulation, which influences the Earth's climate. And a schematic description of the general circulation is shown in figure. Now we will see the figure also. Before that, friends, just go through the pattern of wind direction in cyclones and anticyclones. Now, so I hope you have completed the box or the table, like pressure system, pressure condition at the center, then pattern of wind direction. See, cyclone where pressure condition at the center is low, whereas pattern of wind direction in northern hemisphere anti-clockwise and southern hemisphere clockwise. Again, in anticyclone, the pressure condition at the center high, the pattern of wind direction in northern hemisphere clockwise and southern hemisphere anti-clockwise. Now, see the simplified general circulation of the atmosphere. Now friends, it will take 3-4 minutes to write down and diagram. So just make rough draft Then we will discuss about the simplified general circulation of the atmosphere. Now see the intertropical convergence zone ITCZ, which rises because of the convection caused by high insolation and a low pressure is created. So we will discuss this. Just go through the diagram first, or you can make rough diagram, take 3 4 5 minutes, then we will discuss in detail. I hope now it's visible to you all. So just go through the diagram and then we'll discuss within 4 to 5 minutes the further topics. Please make outline or the diagram of simplified general circulation of the atmosphere. Yes, now friends, I hope you have draw the complete diagram. Now, we'll discuss the air at the intertropical convergence zone ITCZ, which rises because of convection caused by high isolation and low pressure is created. Yes. So friends, here the air at the intertropical convergence zone rises because of convection caused by high insolation and a low pressure is created. Now, see, the converged air rises along with the convective sail now it reaches the top of the troposphere up to an altitude of 14 kilometers and moves towards the poles. Now, friends, this accumulation or this causes accumulation of air at about 30 degrees north and south. So part of accumulated air sinks to the ground and forms a subtropical high. Now another reason for sinking is the cooling of air when it reaches 30 degrees north and south latitudes. So therefore, down below near the land surface, the air flows towards the equator as the easterlies and the easterlies from either side of the equator converge in ITCZ. So friends, such circulations from the surface upwards and vice versa are called sails, and such a sail in the tropics is called Hadley sail. Now, in the middle latitudes, the circulation is that of sinking cold air that comes from the poles and the rising warm air that blows from the subtropical high. So at the surface, these winds are called westerlies, and the sail is known as the Farrell sail. Yes, now friends, here are the small terms like westerlies, northeast trades, southeast trades. Now, in the middle latitudes, the circulation is that of sinking cold air that comes from the poles and the rising warm air that blows from the subtropical high. Now, at the surface, these winds are called westerlies and the sail is known as feral sail. Now, at polar latitudes, the cold, dense air subsides near the poles and blows towards middle latitudes as the polar easterlies. Now, this is called as polar sail. Sorry. So, here at polar latitudes, the cold dense air subsides near the poles and blows towards middle latitudes as the polar easterlies. So this sail is called the polar sail. Now, these three sails set pattern for the general circulation of the atmosphere and the transfer of heat energy from lower latitudes to higher latitudes, which maintain the general circulation. Now, this general circulation of the atmosphere, which also affects the oceans and the large scale winds of the atmosphere, which initiate large and slow moving currents of the ocean. So basically, oceans in turn provide input of energy and water vapor into the air, and these interactions take place rather slowly over a large part of the ocean. Now, this general atmospheric circulation and its effect on oceans we will discuss. Before that, here see the once again will revise the general circulation of the atmosphere. Now understand, the pattern of planetary winds largely depends on latitudinal variation of atmospheric heating, emergence of pressure belts, the migration of belts following apparent path of the sun, and the distribution of continents and oceans. Now, and the rotation of Earth. So the pattern of the movement of the planetary winds is called the general circulation of the atmosphere, and the general circulation of the atmosphere which also sets in motion the ocean water circulation, which influences the Earth's climate. A schematic description of the general circulation is shown here in the diagram itself. Now, polar vortex at North Pole. So, simplified general circulation of the atmosphere now the air at the ITCZ, which rises because of convection caused by high insolation and low pressure, is created. So the winds from the tropics converge at this low pressure zone, and the converged air rises along the convective sail. Now, so basically the converged air rise along with the convective sail. It reaches the top of the troposphere up to an altitude of 14 kilometers and moves towards the poles. Now this causes accumulation of air at about 30° north and south. Part of the accumulated air sinks to the ground and forms a subtropical high. Another reason for sinking is the cooling of air when it reaches 30° north and south latitudes. Now, down below near the land surface, the air flows towards the equator as the easterlies, and the easterlies from either side of the equator converge in the Intertropical Convergence Zone ITCZ. So such circulations from the surface upwards and vice versa are called sails. So such a sail in the tropic is called Hadley sail. In the middle latitudes, the circulation of the sinking cold air that comes from the poles and the rising warm air that blows from the subtropical high. So at the surface, these winds are called westerlies and the sail is known as Ferrel sail. Now, at polar latitudes, the cold dense air subsides near the poles and blows towards middle latitudes as the polar easterlies. So this sail is called the polar sail, and these three sails set the pattern for the general circulation of the atmosphere. Now, the transfer of heat energy from lower latitudes to higher latitudes maintains the general circulation, and the general circulation of the atmosphere, which also affects the oceans. Now the large scale winds of the atmosphere initiate large and slow moving currents of the ocean, and oceans in turn provide input of energy and water vapor into the air. So these interactions take place rather slowly over a large part of the ocean. Now, see the general atmospheric circulation and its effect on ocean. So, warming and cooling of the Pacific Ocean is most important in terms of general atmospheric circulation. The warm water of the Central Pacific Ocean slowly drifts towards South American coast and replaces the cool Peruvian current. Such appearance of warm water of the coast of Peru is known as the El Nino, and the El Nino event is closely associated with the pressure changes in the Central Pacific and Australia. Now, this change in pressure condition over Pacific is known as the Southern Oscillation, and the combined phenomenon of Southern Oscillation and El Nino is known as INSO. Now, in the years when the INSO is strong, large scale variations in weather occur over the world, and the arid west coast of South America receives heavy rainfall. Drought occurs in Australia and sometimes in India, and floods in China. So, this phenomenon is closely monitored and is used for long range forecasting in major parts of the world. Yes, excuse me. Now, see, this is the general atmospheric circulation and its effects on oceans. Now, after this, we'll discuss about seasonal winds. Now, here we will discuss about seasonal wind. Now friends, the pattern of wind circulation is modified in different seasons due to the shifting of regions of maximum heating, pressure and wind belts. The most pronounced effect of such a shift is noticed in the monsoons, especially over Southeast Asia. Now, the other local deviations from the general circulation system like local winds, land and sea breezes, which we will discuss in the next session. Excuse me. So friends, keep revising what we have covered. In the next session, we will continue with the further topics. Now, we'll discuss about land and sea breezes, local winds, air masses, and mountain and valley winds. Now friends, do not forget to join new batches from 29th September. We have regular batches like 1 year, 2 year batches, and also answer writing program batches for mains from 18th October. So we will cover all important topics for the mains from 18th October. As per your convenience, you can join these batches. There is weekend current affairs special or current affairs simplified batch. Basically in this batch we will cover the maximum sources like newspapers Hindu, Indian Express, magazines like Kurukshetra Yojana, Down to Earth EPW, and other sources like PIB, Rajya Sabha TV and All India Radio. In this course you will get current affairs magazine in soft copy. So from 29 September we are also going to start weekend current affairs simplified batch. You can join this for the current affairs part. And once again we congratulate to all successful candidates who have cracked Civil Services Examination 2020, including Jagriti Avasti, Unacademy learner who secured All India rank 2nd. There are 169 plus candidates. Unacademy learners cracked the examination. So friends, now next time you will be in the list. So keep studying with the Unacademy. We will guide you throughout your UPSC CSE journey. Now here is the limited period offer till 30th September. We have 10% additional discount. You can use code RBI Live Now, in this, for the plus combo subscription of 1 year, you have to pay only 46,740 rupees. And for the 1 year of iconic combo, you have to pay 63,989 rupees. So friends, as per your convenience, you can join these courses. You will get additional 10% discount till 30th September. Do not forget to use referral code RBI Live for the registering of registration of our paid subscriptions. And do not forget to enroll yourself for UPSC Combat. This time we have Geographic Combat on 3rd October morning 11 am. The link is provided in the description box. It's absolutely free for all aspirants. You can use invite code RBI Live to register for the Geographic Combat. There will be amazing prizes and scholarships. Yes, we'll provide you study material in a hard copy worth rupees 10,000, absolutely free with 1 year and above subscription. And those aspirants facing financial constraint, they can go with the no cost EMI or loan facilities, where Unacademy is providing you the loan facility. The link is provided in the description box. You can also avail 10% discount using code RBI Live. So just let's crack it and chase your UPSC dream with Unacademy. And last but not the least, do not forget to enroll yourself for free test series. Now friends, in this free test series, you will practice maximum tests. You can unlock the test using code RBI Live. The link is provided in the description box. So hurry up, register and start practice and evaluation of your preparation. Friends, do not forget to like the video. You can share the links with your friends also. Stay tuned. Keep watching Unacademy videos. See you in the next lecture with the remaining topic of our this fundamentals of physical geography. Stay home, stay safe, get vaccinated, take care,